So, hello, good afternoon, everybody. My name is Jesus Benedicto from Atos, and together with my colleague Sudeep from Uninova, we're going to present you the Shopfloor data collection specific enabler. Then, our intention in the agenda is to, first of all, we're going to see an overview of the component, and then we will continue with the details of each of the submodules that make up this component, which are the Fitman Tag Trace and the Fitman Sensor Network. Regarding the component, the Fitman Shopfloor data collection specific enabler is a collection of modules, more concretely two components, the Fitman Tag Trace and the Fitman Sensor Networks, which can be deployed and used independently, and these both components are dedicated for the collection of data from the shop floor. Therefore, allows to capture and acquire data from tagged objects, for example, for RFID, and also from networks and wireless sensors. These two components are basically developed based on reusable components coming from other open source projects and also for deliverables from my RSA cluster. Then, if we go through these two components, the Fitman Tag Trace is based on Fosstrak, which is an open source RFID software platform that implements the GC1 APC network specifications. And the main goal is to provide core components for APC electronic product code network applications. Let's to understand a little bit, the APC global network is responsible for the standardization of the electronic product code, the APC, and aims to facilitate the information exchange and negotiation between physical objects. So this is in charge to define standards for data and also for information exchange. Also, in parallel, includes the specification for RFID devices and also the rules that manage the APC's data coding in this device, in RFID devices. And also is in charge to define the interfaces between the systems components that facilitate the interoperability of components produced by different manufacturers. Regarding the APC, this is an identification and naming schema designed to identify univocally among the participants' countries all the physical objects, also virtual and service commercialized. And the unique identity means simply to assign a name to the entity in such a way that a certain name is different from any other assigned by another entity. So with this, we're ensuring that there is not possible to have two products with the same APC. This code is composed or is divided into two different parts. One that identifies the manufacturer, and the other one the producer type. However, the APC also uses an additional set of digits, which are a serial number for exclusivity and identification for each product. Then, basically, this is this APC global network is structured in more or less 6 different parts. One of them is the APC number, which is the global and exclusive identifier. Then we have the reader of interrogator for data capture devices. Also, we have the APC middleware, software in charge to control the readers. The ALE of application level events specification. This is an interface and standard application level developed by this APC Global that allow customers to obtain consolidated and filtered APC observation from a variety of sources. And then we have the APC information service, the APCs, that contains all the data for our electronic product code. So then, this is in reference to the Fitman Tag Trace. And regarding the Fitman Sensor Network, this one is based on the GCN. This is a middleware for rapid deployment and integration of heterogeneous wireless sensor networks. It's in charge of acquisition, filtering, and query of data collected from Shopfloor through sensor networks. And both of these modules are, as I said before, are used for data acquisition, basically for the shop floors. But in any case, it's also extrapolable for other domains. And both of them expose REST interfaces to service consumers for management and query, and also for the communication with secure event management. This one is another specific enabler that we have developed in Fitman, who is in charge to develop to distribute the events in a secure way. Then if we go through the Fitman Track and Trace, this component, we propose a middleware based on a standard specification and components to manage RFID tags to capture the associated data related to the product in the supply chain and for dispatch this data to the client application. And also we are changed to provide service to manage the tags, to capture the data from the tags, to manage events, to notify the applications, and also to make queries. For example, we use Shopfloor to know the status of each product, if it is shipped or is still in the manufacturing process, the time information or location of these products, or also can be for an article or pallet or also a container. Just to put in context a little bit, the RFID tags are the radio frequency identification technology is widely used in the supply chain, in which generally there is only a tag read and transfer of the data to the upper layers, generating real-time information for decision making. So for this, usually the RFID architecture is arranged with 3 layers. In the bottom we have the physical layer, which consists on a set of hardware formed by tags, which is a basic structure, which basic structure is a chip capable of storing information. Then we have antennas that can be fixed or mobile, receivers and transmitter, and then we have the reader or interrogator of the RFID and computers. Then in the second layer, in which is focused this component, is the intermediate layer. It can be an RFID middleware. And here the data provided with the physical layer is summarized and organized to be forwarded to the upper layer, to the application layer. In our case, will be the information services, as we can see before. Then, main object is to develop this model, this component. We'll be able to identify individual products, case, lots, assets, etc. So this kind of individual products can be tracked individually through all the life cycle. We can capture data about the movement of these physical assets, creating visibility for the different parts or departments of the factory, or also between the different headquarters of the factories. We are going to know what, when, where, and also the status or the situation of the specific product. We will be capable to query data about the traceability and tracking of ticket objects. We are going to manage the events and notifications for these products, and for sure we can be able to exchange data with IT application and trading partners to turn visibility into information and action in order to be more efficiency actuation. Then the major requirement for this is this middleware will be focused on the standards and normative references. Will be extensible, interoperable, and scalable. All of this is offered by this middleware. For sure, can be technology independence, and they can provide several security for the different operations. This component is based on the Fosstrak. Fosstrak is a platform, is a RFID open source system that implements the APC network specifications. And basically, Fosstrak meets all the functionality required with a middleware system. It is easy to use, and it has an easy to use intuitive interface. And additionally, it's compliant with the EPC network certificate, and for sure it meets all the EPC standard requirements. Broadly speaking, this platform is divided into 4 modules. The most important is the EPC repository, this provides an EPC Global Certified EPC repository, also a query and capture clients. And the main idea of this functionality is that there is a capture interface implemented by HTTP that allows us to generate and capture events and sends them to the EPC repository in order to keep it into a database. Then, once this event is registered inside the database, the user have the data at one's disposal by the query interface through the SOAP environment in order to ask the status of different EPCs, codes, and every information that they need to know regarding the product. Then the second module that has composed by Fosstrak is the filtering and collection middleware with EALE. This module, the Fosstrak EALE middleware, allows us to filter and collect data from RFID readers. Then we have support for low-level reader protocol, LRP. This helps us to configure and manage the LRP compliant RFID readers. And finally, we have these several client applications. This is more or less the structure of the EALE middleware. As you can see, they offer different interfaces. In the bottom of the graphic, we have the different RFID readers. We have the Intermec, the Motorola, Inpignic, for which are LRP compliant. We have an LRP adapter, which is supported by this middleware. And for those that are not compliant with this low-level reader protocol, we have a hardware abstraction layer called HOL, which will facilitate in order to encode and decoding the different information. And then just in the top in the image, we have the relation with the EPC repository, which is the component that we will see in the next slides. So this middleware is comprised by 3 separate modules: the filtering and collection server, and a standalone client to configure a filtering and collection service, and also a web-based client to configure a collection service. So we can access through the navigator and also for a client application. Then these are more characteristics of the middleware, but basically we will use this component in order to communicate the readers with the system. In the lower layers of the Fosstrak, we have the EPC repository. As you can see here, it's comprised by 3 separate modules. We have the repository itself, implementation, and then we have 2 different applications. One is for the capture application in order to capture the events, who is sending by the middleware, and then we have another who is in charge to query application in order to retrieve information regarding the EPC event. They allow us to be based in different the query service is based on SOAP protocol, and also provides a capture service and interface based on RESTful and HTTP protocol. Finally, the functionality of the repository is registering and managing different types of events and notifications regarding the data of the EPC. This is more or less the architecture of the component. As you can say before, it's based on Fosstrak, the EALE server in order to manage interaction with the RFID readers. Also, it provides the mechanisms in order to data filtering and collection features. for sure we can manage and query, also have a query interface in order to retrieve the data that is stored here, and allow us to register and manage different types of events to be captured. If we have time at the end, we will see how to configure this middleware for the different modules. Then we can say that the Fitman Tag Trace, the major component is the Fosstrak, who is elevate the abstraction, the level of abstraction for the applications. Also insulate the application from the base details. And it's important also to know that reduce the volume of data from readers to application. They provide the interface based on REST or web service enhancements. So integrates easily using standards that can be XML, web service technologies. It's based on standard protocols, HTTP, HTTPS, and TCP/IP. And also is capable to translate information received in XML format from device to events and in a standardized data format. So regarding the events, we can say that they can answer for questions what, where, when, and why. When we talk about what, is in reference to the APC number. We can know exactly which product it is. Where with this information we can know the location. In this case can be fixed or moving. Also we can know in which moment has produced this event. And we can know exactly why is produced this event. All of this information is stored in each of the event produced by the referee readers. Then this can be an example of how to use the EPC repository and how to share the information among all the different departments involved, on all the different people involved in the overall process. In this case, when the manufacturer produces the product, he is translated by plane to a distribution center, and then from here is also distributed by trucks to the final retailer. Then when the product is exactly shipped, they can produce an event which is stored in the repository, and then people from distribution center or also for the retailer can have access to this information in real time. So they can have the traceability of the product in real time. Also, this can be an data capture sampler for the palletized. In the bottom, we have the different readers. Okay, those are the individual tags read events from a specific antenna. This information is sent into the filtering collection for the ALE server. In this case, we can know what, where, and when. And then when we capture the palletizer by the capture application and is sent to the EPC repository, we can know exactly what, where, when, and why. In this case, the association of these case tags to the following pallet is stored in the EPC repository, indicating that is created at palletizer number 3 to fulfill the specific order. In this case, the 1, 2, 3, 4. This can be, for example, an example of how to use this EPC repository. And to finalize for the Fitman Tag Trace, we can see an example of XML message and also the refi data managed by the ALE. Here we can see that is a post, is a message in XML sent to HTTP. Here and inside the message we can know specific data from this message is related to the specific current specification, and also we have here the EPC electronic product code reflected in the message together with the timestamp in which it has been produced. So now my colleague Sudeep will will explain us the Fitman Sensor Network.
Hello everyone, I'm Sudeep. And now I'll be talking about other component of this enabler. So it's a FitmanSN or Fitman Sensor Network. This component is for the case when the data producers are sensors, like the other component was when the data producers was RFIDs. So this case is for the case when you have sensor for sensors and have a collection of sensor networks. This is mainly used for monitoring purposes on the soft floor. So the main idea behind this component is to provide one unique framework that can be used for data collection from different types of sensor networks by making use of one uniform approach. The big advantage that this component provides is provides an abstraction from the implementation details that the end users have to consider while trying to use different types of sensors. So now, even when we have different types of sensors, you don't have to go into the specific requirements of the sensors because now we provide a higher abstraction layer where they can work with a uniform format. And also we provide HTTP-based binding so that the end users or the data consumers can query the sensors, the data being produced at the sensors through a simple HTTP REST interface. And we would also provide the subscription and management functionalities so that data being produced at the source can be notified at the right time to the end consumers. And also we have integration with the other enabler that can help to securely transform events being produced on the software to higher other consumers. Yeah, and so now this is the high-level architecture for this component. So this component is based on GSN, which is produced by another project in the IRC cluster. So we took the main components from that delivered from the project and customized it and added new functionalities to make it more usable. So the basic idea is the GSN is composed of virtual sensors, virtual sensor processors, and a way to how to describe the virtual sensors. So the main idea behind this is to virtualize the actual physical sensors as a virtual resource, so that the applications can consume data in a more higher level. And we also provide interfaces for management and query, and also for configuration of events and notifications. Yeah, so as we had seen from the previous slides, the major components of Fitman Sensor Network components are the wrappers. So the wrappers are the actual implementations that do the collection of data from the sensors. So this is the actual code that has to be written. So these are like the actual implementations that distinguish each of the sensors. So when these wrappers are written, then from the other layers, you don't have to know the implementation details. So it means that there can be one developer who is writing the wrappers, while there can be other persons who can use them now without having to understand the details regarding the sensors. So this is where we define the virtual sensors. So virtual sensor is the way to abstract over the real sensors. And these virtual sensors have the feature where you can define to aggregate or filter data that is being populated from the real sensors. And these virtual sensors are defined by making use of the virtual sensor description files. These are simple XML files, which we will see as an example in the next one. And here, in order to query the real physical sensors, we can write SQL-like queries. So it makes it more readable. So, and then in addition, you can write virtual sensor processing classes that can be used for actually processing the data that is being collected from the sensors. So here's an example of a virtual sensor description. So the main idea is to find a way how to virtualize a real physical sensor. So here we created a simple virtual sensor. So it has the name. So we said it's a temperature handler. And then when you do this, you can choose the. So we have this class name. So this is the processing class, and that actually implements the necessary functionalities to collect the temperature from the sensor. So this is class name. Sorry, back please. Okay, yeah, and then when you define these wrappers, as you can see in the last highlighted part, you can really write the query as SQL query. So we say that this is from the source that has been defined. Select the parameters light and temperature. Yeah. These are some functionalities that has been implemented through the REST interface. So all the functionalities that you will be accessing through the REST are of the format. You have the server URL, JSON, and the request, and you have the request type. So there are a number of request types that we can see here. So you can add new virtual sensors, remove it, request the list of virtual sensors, and you can write queries over the virtual sensors by providing a number of conditions. And at the same time, you can also ask for all the data that has been recorded by the particular sensors, and also you can send a shutdown request to close a particular JSON component or sensor networks component. Yeah, so this was previously this is described the components for the Tag Trace, and then we had the global sensor networks part, and then this is the next plan that we have to enrich the functionalities of the enabler, Shopfloor data collection enabler. So the functionalities that we described before are for the month 24 release, which is like the current version. And then in the next steps, we want to provide distributed data storage setup. So this will be important to separate between the data that will be data repository for processing and for storage, so that we can have the future traceability of all the events, and also provide publish subscribe features. We already have a small functionality for this, but we want to improve it for the next releases. And in the end, we really want to provide integrated API for FitmanT&T and for the SN. Now we have separate APIs for both of them, so we want to make a uniform interface for end users in data consumers. So that will be for month 14 release